So let's talk about something huge that's happening right now in the energy world. We're in the middle of a historic reshuffling of money and investment. Looking ahead to 2026, we're seeing billions of dollars move from old technologies to new ones, creating a whole new set of winners and losers in the race to power our future. And this quote, man, it just nails the central problem, doesn't it? The whole world is pouring money into a cleaner energy future, but there's a huge fundamental issue. What happens when the sun isn't shining or the wind isn't blowing? How are you supposed to power a 24/7 economy with energy that just isn't always there? But here's the twist. Even with that major reliability challenge, the growth of renewables is absolutely undeniable. I mean, look at this. The US is on track to get a full quarter of all its electricity from renewables by 2026. This creates this really interesting tension, right? The explosive growth is actually what's shining a huge spotlight on a key weakness. Which, of course, brings us to the big question for this entire explainer. How do we solve this puzzle? How do we build a clean energy grid that can deliver the round-the-clock, never-sleeps reliability that our modern world absolutely demands? All right, so to figure that out, here's our game plan. We're going to start with the new energy landscape. Then, look at the established powerhouses, the fuel of the future, a real unsung hero, and the essential ingredient that kind of ties it all together. And then we'll wrap up with how to navigate this whole transition. First up, let's dive into the new energy landscape, which is really the story of incredible growth slamming right into that fundamental challenge of reliability. And you've got to understand, this isn't just a US story. We're talking about a global phenomenon. The International Energy Agency is projecting that by 2026, renewables will actually overtake coal as the world's #1 source of electricity. That is a monumental shift that's happening as we speak. So let's talk about the technologies that got us here in the first place, the absolute titans of solar and wind. This really gives you a sense of the sheer scale we're talking about. You've got First Solar, a US manufacturing beast, with so many orders that their backlog is full all the way out to 2030. Then there's NextEra Energy, the biggest renewable producer out there, planning to add an insane 46.5 gigawatts of new projects. And Vestas, the world's top wind turbine maker, has this massive business just servicing turbines. It's a huge, stable revenue stream. These are the heavyweights for sure. Okay, but here's the thing. Solar and wind are amazing, but they can't decarbonize every single industry. And that brings us to our next big topic, hydrogen. This could be the answer for the really tough stuff, like heavy industry and long-haul transport. Now, it's super important to know that not all clean hydrogen is created equal. You've got green hydrogen on one side. That's the gold standard. It's made with renewable energy, and it's totally emission-free. Then you have blue hydrogen, which is made from natural gas. It captures the carbon, so it's lower carbon, but it's not zero. That distinction is absolutely critical. And you can really see the different strategies companies are taking here. You've got the giants, like Air Products, going for these massive mega projects. Then you've got pioneers like Plug Power, who are all in on things like forklifts and delivery vans. And then there are the specialists, like Bloom Energy, who are targeting a very specific market, data centers, with super efficient on-site power. It's fascinating. Okay, so remember that reliability problem we kicked things off with? Well, let's talk about a potential solution. And it's a bit of an unsung hero in the energy world. Geothermal. So for the longest time, geothermal power was stuck. You could only build it in very specific places with the right geology. But that is all changing thanks to something called Enhanced Geothermal Systems, or EGS. This is a total game changer. It basically borrows drilling tech from the oil and gas industry to create power plants pretty much anywhere you can find hot rock. So how does this work? It's actually pretty wild. Think of it like building a power plant deep underground. First, you drill way, way down. Second, you fracture the rock to create a bunch of little pathways. Third, you pump water in. And finally, that super hot rock instantly turns the water into steam, which comes screaming back to the surface to generate clean, reliable 24/7 power. So who's buying this stuff? Well, a huge customer for this always-on power is the tech world. Think about it. Data centers for companies like Google need a constant, uninterrupted stream of power to keep the cloud running. They can't afford blackouts. This has created a massive demand that's really helping to fuel the growth in geothermal. Okay, so let's shift gears to a key ingredient that underpins so much of this transition. Whether we're talking about storing wind and solar energy on the grid or powering electric cars, it all comes down to batteries. And a key part of those batteries is lithium. And just look at this number to get a sense of the scale. 285,000 metric tons. That's the projected global demand for lithium in 2025. This is just a massive, massive leap, and it's all being driven by the explosion in electric vehicles and the desperate need for huge batteries to back up the grid. And this explosion in demand has kicked off a global gold rush, or I guess a lithium rush. You've got the established giants like Albemarle and SQM pulling lithium out of the rich salt flats in Chile. At the same time, you've got other companies scrambling to develop projects everywhere from the hard rock mines of Australia to the emerging fields in Argentina. All right, we have covered a ton of ground. So for our last section, let's pull it all together and create a kind of compass for how to think about this incredibly complex energy transition. This table really helps put everything into perspective. You can see how each technology fits. Solar and wind? They're mature, but they have that intermittency problem. Hydrogen? It's still pretty early, and the biggest challenge is getting the cost down. Geothermal is getting there, but it costs a fortune to get started. And lithium? Well, that's a growth story that's all about supply chain headaches. Each one has a totally different risk and reward profile. And this brings us to a really crucial takeaway. As this quote points out, the days of just buying a clean energy fund and calling it a day, those are probably over. We're moving into a much more selective world where you really have to understand the specific companies and technologies to succeed. So the bottom line is crystal clear, right? There is no magic wand here, no single silver bullet that's going to solve everything. The future grid isn't going to be just one thing. It's going to be a complex, interconnected mix of all these powerful technologies, each playing to its strengths. And that leaves us with one final thought. This great energy reshuffle is well underway. All these technologies we've talked about are out there, competing and sometimes collaborating to build our energy future. The big question for all of us is, which of these stories do you think will be the ones powering our world for the next decade and beyond?